All right, welcome. In this video, we are going to be talking about the end behavior of functions as well as horizontal asymptotes. We've already really examined vertical asymptotes, but now we want to say, well, what about horizontal asymptotes? So first off, end behavior. End behavior is what happens at either end of the function. And when I talk about either end of the function, I mean the left end of the function and the right end of the function. So as x goes towards negative infinity or as x goes towards positive infinity. And one way that we talk about end behavior and right end behavior is using limits. So we say, what is the limit of f of x as x goes to infinity? So this is saying what happens to my y values as I go all the way to the right. All right, this is known as the right end behavior because x is going towards positive infinity. So this is the right end behavior. On the other hand, my limit of f of x as x goes to negative infinity. So what is my y value approaching as I go all the way to the left? This here is my left end behavior. All right, and again, you guys will never have to write the limits out, but you will have to be able to recognize them and understand what they mean. For the left end behavior, it's saying as x goes to negative infinity. So as I go all the way to the left on the graph, what is my y value approaching? All right, so now getting into these horizontal asymptotes. And horizontal asymptotes actually tell us what the end behavior of the function is. So we've already kind of discussed vertical asymptotes. So looking at this vertical asymptote right here, okay, we can see as I approach the vertical asymptote, my y values either go to positive infinity or negative infinity. For the horizontal asymptotes, this is some value that I approach. I'll say y equals, let's just call it h for the horizontal asymptote. Okay, that's the y value that I'm going to be approaching as my x goes to positive or negative infinity. So in some cases, maybe my x is going up to positive infinity and my y value approaches y equals 1, or y equals 0, y equals 4. Okay, it's some value that as I scroll further and further along that graph, it's going to get closer and closer to that value, but never actually touch it. So, finding the horizontal asymptote. What we need to do is see what happens as x gets very large. What happens as x goes to positive infinity? Am I approaching some value, or is my function just going to continue to grow? So you can think of it as we're just plugging in a very large number to x, and we're going to see what do we get out of that. So let's do an example. This says find the horizontal asymptote of f of x equals x minus 3 over x squared plus 2x minus 5. So let's imagine that we're plugging in a massive number. So we're plugging in 1 billion. If I plug that into my numerator, 1 billion minus 3, does the minus 3 really even matter? No, right? I plug in a really large number, minus 3, 1 billion minus 3, that gives me 999 million, ... All right, it's still an incredibly large number. Same thing in the denominator. If I plug in 1 billion and I square it, that's going to be so much greater than just 2 times 1 billion, right? 1 billion squared, all of a sudden now it has 18 zeros instead of 9 zeros. And then the minus 5, that's not going to matter. So as x goes to positive infinity, this function, so as x gets very large, okay, this function can really be approximated just by taking the term with the highest degree or the highest exponent in both the numerator and the denominator. So this will look the same as x over x squared. Well, x over x squared, we could simplify that to just 1 over x. And 1 over x, well, what's going to happen if I plug in a really large number for x? Again, we're plugging in, seeing what happens as x gets very large. Well, 1 divided by a billion is just about 0. So as x goes to infinity, this is going to go to 0. 1 over infinity can be approximated by 0. All right, so that tells me my horizontal asymptote is 0. And of course, it's a line, so we need to write the equation of that line. It's a horizontal line, so my asymptote is y equals 0. As far as end behavior is concerned, well, my asymptote tells me what value I will approach. So the limit of f of x as x goes to infinity is just going to be 0. So that's my right end behavior. Same thing with my left end behavior. 1 divided by negative infinity, well, 1 over negative 1 billion is like negative 0.000001. So my left end behavior will also approach the asymptote. All right, if you have a horizontal asymptote, both your right end behavior and left end behavior will both approach that value. So as x approaches negative infinity, it will be 0 as well. All right, let's move on to the next one. Let's find the horizontal asymptote. So again, as x gets really, really large, I could just approximate this by saying, well, this is the same thing as just 3x squared over 2x squared as x gets really large, because the plus 12 isn't going to matter. The minus 4 isn't going to matter. If there was an x to the first power, that wouldn't matter. Okay, because as x gets really, really large, the only one that really matters is the term with the highest exponent. Well, 3x squared over 2x squared, we could simplify that to just 3 over 2. And so as x gets really large, this is going to approach 3 over 2. So that's going to be my horizontal asymptote is 3/2. All right, and again, we could write our left and right end behavior. Limit of f of x as x approaches infinity is 3/2. And the limit of f of x as x approaches negative infinity, so the left end behavior, is also 3/2. Let's actually take a look at this on Desmos. So 3x squared plus 12 over 2x squared minus 4. Oh, I don't have it opened up. Let's just check it out here. And whenever it's ready. All right, 3x squared plus 12, I believe. And then divided by 2x squared minus 4. All right, so we're saying as x goes to positive or negative infinity, it's approaching 1.5, 1.5. So let's take a look at this. And we can kind of see that that looks like it's true. Let's just get some values. Is it going to let me click on this? Let's see. So as we go to the right, 1.553, 1.521, 1.517. So as we go to the right, yep, it's going to 1.5. As we go to the left, let's see that. And same exact thing, 1.513, 1.512. So as we go to the left and the right, we can clearly see it's approaching 3/2 or 1.5. All right, and for this last one, find the horizontal asymptote of h of x equals x cubed minus 8 over 2x squared plus 5. Well, as x gets really large, all we care about is x cubed over 2x squared. We can approximate it just using this. X cubed over 2x squared. And x cubed over x squared, well, we could simplify that to just an x to the first in the numerator, x over 2. Now imagine, well, what's going to happen with x divided by 2 as x gets infinitely large, right? If x is 1 billion and then you divide it by 2, it's still going to be a really large number. It's going to go to 500 million, right? And as x increases, x over 2 will continue to increase. So in this case, there is no horizontal asymptote. Okay, no horizontal asymptote. Because it's just going to continue to increase as x increases. It's going to continue to decrease as x goes further and further and further to negative infinity. So in this case, my left end behavior, so as x goes to negative infinity, my y value will also continue to decrease to negative infinity. As x goes to positive infinity, my y value will also continue to increase to positive infinity. Let's check this out. X cubed minus 8 over 2x squared plus 5. Okay, let's just delete this. Delete. What I say? X cubed minus 8x to the third minus 8 divided by 2x squared plus 5. So we kind of have an interesting graph here, and we can see that these just continue to increase. Okay, it just continues to increase as we go to the right. It continues to decrease as we go to the left. All right, and we can approximate that really just by plugging in, okay, what's going to happen as x gets really, really large or really, really negative. All right, so now let's just kind of develop some shortcuts here. So I'm going to say m is the leading exponent in the numerator and n is the leading or highest exponent in the denominator. So what happens if the exponent in the numerator is less than the exponent in the denominator? You'll find that in those cases, my horizontal asymptote, my HA, will be y equals 0. Okay, it'll be y equals 0. Why? What's going to happen? Well, you could be left with like a 1 over x, right? When we're approximating as x gets really, really large, you get left with 1 over x. You plug in infinity to the denominator, 1 divided by a really large number goes to 0. If m is equal to n, so if the exponent in the numerator equals the highest exponent in the denominator, well, in that case, when you just take those leading terms, those x, maybe they're both x cubed, those will cancel each other out, and all you're left with is the coefficients, okay, the coefficients. So y is equal to coefficient of the numerator divided by the coefficient of the denominator. Okay, and I don't necessarily recommend memorizing these, but if you are completely lost and struggling, then maybe this will be helpful for you. Okay, and then if m is greater than n, so if the exponent in the numerator is greater, well, when you simplify it down, that means that you're still going to have an x in the numerator. So as x goes to infinity, the function will also go to infinity. So there is no horizontal asymptote if the exponent in the numerator is greater than the highest exponent in the denominator.